Ahoy, me mateys! Arr! Today we're going to learn about miscellaneous ideas that pertain to trig functions. So to be honest, there's nothing brand spanking new in this video, but we're going to try to take pieces from everything we have learned and really try to connect and tie them together. So this topic is really all about making connections. I really want everyone to not only understand all aspects of trigonomic functions, but to see how all the skills and concepts we've been learning are all connected and intertwined. And it all begins with that beautiful, wonderful unit circle. Here's the deal, guys. The unit circle is filled with points. Pick any point. Grab a point on the unit circle right here. That point has several things related to it. First, it has a point. That's an X. That's a Y. That point also is a certain distance away from the origin or from the vertex or from the center of the circle, and we call that distance the radius. And if we're working with the unit circle, that radius is 1. And we could also look at the angle that was terminating at that side. We'll call that theta. And we can even draw a triangle based on that angle by dropping this side straight down at a 90-degree angle and bringing this straight over, making the height or the opposite side of the angle y, the y coordinate from the unit circle, and the adjacent side x, or the x coordinate of the point. So I'm literally connecting every single thing we've been learning. If you look at this triangle and I say, hey, what is sine of theta? Well, you could look at the triangle and say, well, it's the opposite divided by the hypotenuse or radius. But if that radius is 1, then it's just y, the y coordinate from the unit circle. Everything gets tied together. Cosine of that angle is x divided by the radius. But if that radius is 1, because we're on the unit circle, it's just x, the x coordinate of that point where the angle terminated. Tangent of that angle is the y divided by the x. So if obviously tangent doesn't utilize r, so it doesn't even matter if r is bigger or smaller than 1, but if you're on the unit circle, it is 1. It's the y coordinate divided by the x coordinate. Then of course we have the reciprocals. That's just easy because all I got to do is reciprocate. Cosecant is 1 over y. Secant, 1 over x. Cotangent, x over y. Easy, 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 easy. So all of these values are connected. And the other way that they're connected is that we know that x squared plus y squared, that's a bad y squared equals r squared, because it's a right triangle, so that's Pythagorean's theorem. X squared plus y squared equals r squared. And if that radius is 1, because we're on the unit circle, well then x squared plus y squared equals 1. It's all tied together, guys. So let's look at how I only really need to give you any one of these tiny, tiny features, and you should be able to find everything else. So here's a good problem to analyze. So notice here we have a point on the unit circle, and I'm giving you the x value, but I'm not giving you the y value. We're going to find it. But we do know that this also creates a line or an angle, and there is the angle. It's obviously somewhere between 90 degrees or pi over 2 radians and 180 degrees or pi radians. So that's my angle theta there. Okay, so let's connect everything together. Whoop, I don't know what happened to my line there. Sorry. All right, so the first thing that's pretty important is if I say, hey, what's cosine? Well, listen, you don't need to do any work to find cosine. Cosine of the angle, the output is the x coordinate from the unit circle, negative radical 5 over 4. Easy. But sine is the y coordinate, which I don't know. Tangent is the y divided by the x, and that means I need to know the y. So how do I find that y coordinate? Well, listen, when you're on the unit circle, x squared plus y squared equals 1. Now, let's clarify a little bit more things. How do I know I'm on the unit circle? Well, when I'm on the unit circle, we know that you have to, well, first, you know that this applies, right? I mean, this has to be true. If that's not true, you're not on the unit circle. The other thing is that the highest the y coordinate could be is 1, the lowest the y coordinate could be is -1, and the lowest the x coordinate could be is -1, and the biggest the x coordinate could be is 1. So one thing I could do real quickly, just kind of, really tie all this together, is actually, this is an exact value, negative radical 5 over 4. Let's find the approximate value. So I'm going to go to my calculator. I'm going to type in negative square root of 5. Make sure you move the cursor over so you're no longer in the square root. Divided by 4. It is about negative 0.559. So negative 0.559. So that makes sense. My picture might be a little bit off. You know, whatever. It's just a picture. But this x value right here, the x coordinate of that point is negative 0.599. So because it's within negative 1, it's within negative 1 to 1, then there's a great chance, again, I'm on the unit circle. Okay, so the question I need to figure out is what the heck is that y coordinate? Well, again, use this. It's so easy. So the first thing I do is I got to square x. That's 5 over 16. Now, if you don't understand how I got that, then you need to go back to algebra 2. But I literally just squared this. A negative squared is always positive. Radical 5 squared is just 5. 4 squared is 16. Then I'm going to subtract that over. So I'm going to take 1. I'm going to subtract the 5 over 16. Now, you can certainly grab a calculator, but come on, guys, let's be smart. 1 is 16 sixteenths. So 16 sixteenths minus 5 sixteenths is 11 sixteenths. So y squared equals 11 sixteenths. Take the square root, take the square root. Now, when you take a square root, you do have to consider that it could be positive or it could be negative. Now, how do I know it's definitely positive? Because look at my point. It's in quadrant 2. In quadrant 2, x's are certainly negative, but y's need to be positive because I'm up. And the square root of 11, unfortunately, cannot be reduced, but the square root of 16, the denominator is 4. So there it is. There is my secret y coordinate. That's no longer a secret. The square root of 11 over 4. And again, grab your calculator. Get an approximation just so you could see this. The square root of, not 111, sorry about that. Square root of 11 divided by 4 is 0.829. So 0.829, again, I'm sorry for my poorly drawn picture, but the y coordinate of that point is 0.829, approximately, exactly. It's radical 11 over 4. Of course, I'd rather you be exact, but I just wanted you to understand that there is an approximate value there. All right, so hopefully, you know, we're making connections. So again, another question I could ask is, well, what is this angle? You know, what is this angle? Well, oh boy, well, let's see here. How do I find the angle? Well, let's see here. Hey, check this out. I know that cosine of theta equals negative radical 5 over 4. And I also now know that sine of theta equals positive radical 11 over 4. I know that as well. I could actually use either one of these equations, but I'm going to use the one I wrote down first up here. And how do I find theta? Well, I need to pull the old, I literally just spun around in my classroom, the old switcheroo. So I'm simply going to use an inverse cosine, put the negative radical 5 over 4 inside, and the output is the angle. Oh my gosh. Now, let's do degrees first. I don't necessarily love degrees, but I know a lot of you do. Sometimes degrees are easier to see and understand, but we'll do radians as well. So I'm going to in degree modes. That's good. So I'm going to go and do an inverse cosine of negative square root of 5. Make sure you move outside of that square root of 5 for the divide by 4. And boom, it's 123.988 degrees. 123.988 degrees. Look at that. Look at that. That makes sense. I already knew the angle was somewhere between 90 and 180 because the fact I was in quadrant 2. So there's my angle, 123.988 degrees. Remember, cosine inverse is only allowed to give answers that are in quadrants 1 and 2, from 0 to 180 or 0 to pi. So again, that makes a lot of sense. But again, I want to make connections. So let's say we chose to use the sine. We know that sine of that angle, the y coordinate from the unit circle, is radical 11 over 4. So I could also pull the old switcheroo with the inverse sine. Inverse sine of radical 11. I don't know why that keeps happening, sorry. Move outside the radical, divide by 4, and we get, oh boy. We certainly don't get 123.988 degrees. Why are we getting something else? What the heck is going on here? Okay, let me explain. Again, try to make connections. Remember that inverse sine, as well as inverse tangent, is only allowed to give answers up to 90 degrees, pi over 2, or down to negative 90, negative pi over 2. So they're giving me the answer that they're allowed to give me. They're giving me this angle right here that would have the same y coordinate, but they're giving me the answer that's in quadrant 1, 56 point, what was it again? 012 degrees. 012. Sorry, I'm writing small there. So again, that's the answer that they're allowed to give me, right? Inverse functions are restricted to only giving you certain answers, but you have to be able to make connections. That's obviously not the angle I have marked in red. The angle I have marked in red, first off, we already know it's 123.98 degrees because we know we're in quadrant 2. But again, I want you to understand why the inverse sine does work. So you have to understand that inverse sine is only going to give you the positive angle that we see in quadrant 1. But you know, due to symmetry, if this blue angle is 56.012 degrees, so is this angle. We call that the reference angle, 56.012 degrees. So, just to confirm, if I take 180 degrees, a full half circle, and subtract the 56, watch what happens. 180 degrees minus the 56.012. Get ready to have your minds blown. Whoa, 123.988 degrees. So that's the angle I want. I want the answer to be 123.988 degrees. But what you have to understand is that when you use cosine inverse, you get that answer, which is great. When you use sine inverse, you don't get that answer directly. You have to see the connection that inverse sine is only allowed to give answers up to 90 degrees. It's not allowed to go past. But you do have to understand that that 56-degree angle would be symmetric to the 56-degree angle on the other side, and then you could just subtract from 180 to verify that that angle is 123.988 degrees. And the one other thing I really want to connect that I've been kind of trying to emphasize in these videos is that what quadrant you're in matters a ton. So that's why you needed to recognize that we were in quadrant 2 based on my picture, so you could really truly make sure that you give the correct answer for what that angle is. Now let's do a couple other things that I think are pretty cool just to kind of see connections. Now that I know the angle, let's go full circle here. So let's see here. Cosine of 123.988 degrees. Remember, the input to cosine is an angle. The output is, of course, the x-coordinate. Notice that x-coordinate, negative 0.599, which is exactly what, well, not exactly, it's roughly because of rounding, but that is the radical 5 divided by 4 that started this whole problem off. Look at that. Pretty close. Again, it's off a little bit due to rounding. Same thing, sorry, I'm losing my calculator here. Same thing with sine. Sine of 123.988 degrees is 0.829, which guess what? Is the radical 11 divided by 4 that we found. So again, I'm coming full circle back to understanding how all of this is connected. I truly hope you understand that. Let's do another problem here. Now this time we're in quadrant 4. So we're down here in quadrant 4. And now listen, I don't care how you got there. Maybe we went straight down to get that angle. That would be negative. Or maybe we went all the way around. It doesn't matter. The point is that we stopped on this side that has a y-coordinate of negative 2/3 or negative 0.66 repeating. And again, I don't know what the x-coordinate is. So I do know the y-coordinate's about right here, negative 0.667. But now I got to find the x-coordinate. So how do I find that x-coordinate? Oh my gosh, come on. X squared plus y squared equals 1. X squared plus y squared is 4/9. You better know how I got that. Subtract that 4/9 over. 1 is 9/9. 9/9 minus 4/9 is 5/9. Take the square root. Now remember, when you take a square root, you got to consider that it could be positive or negative. But since I'm in quadrant 4, x's are positive, y's are negative, so I'm going to leave it positive. 5 cannot be reduced, but the square root of 9 is a 3. So there is that missing x-coordinate. How easy was that? So what is cosine of theta? Well, it's the x-coordinate. Radical 5 over 3. It doesn't get much easier than that. What is sine of theta? Negative 2/3. The y-coordinate. Doesn't get much easier than that. What is tangent of theta? Well, I'm going to have to do a little bit of dirty work. I'm making some room for dirty work over here. I'm going to take the y-coordinate, negative 2/3. I'm going to divide by the x-coordinate radical 5 over 3, but instead of dividing, I'm going to multiply by the reciprocal, 3 over radical 5. So the 3's cancel, and I get negative 2 over radical 5, but of course we don't like radicals in the denominator. So I'm going to multiply top and bottom by radical 5, and I get tangent is negative 2 radical 5 over 5. Oh, a lot of good solid math work there, but none of it was very difficult. So even though I started this problem with knowing nothing but a y-coordinate, I was now able to find the x-coordinate, cosine, sine, tangent, and I could even find secant, cosecant, and cotangent. All I got to do is take the reciprocals of those values. For example, secant of theta would be negative 3/2. I mean, come on, it's easy, very simple. All right, what else? Well, what's the angle? I want to find the angle. I want to find the angle theta. Now again, there's actually millions of angles that end here. There's two of them that are very obvious. There's the negative angle that goes straight down. There's the positive angle that goes all the way around. Or I could just continue to add and add and add and add and add and rotate and get more and more angles. But let's for example, let's find the angle, right? Well, let's see here. One thing I could do to find an angle is pull the old switcheroo. So for example, to find theta, I could use any one of these three, but I'm going to go ahead and use sine. So sine inverse, because I have to pull the old switcheroo, of negative 2/3. So I'm pulling the old switcheroo using a inverse. But let's go to mode real quick. We did degrees in the last problem. Let's use radians this problem just for fun. If you don't want to, you can go with degrees, but I'm going to use radians for fun. All right, so here we go. Now I'm going to go and hit enter, and I get negative 0.729, but actually that second 7 would round it up to negative 0.730 radians. Negative 0.730 radians. Now, the negative certainly makes sense because, again, that would be the negative angle going down. Remember, when you use sine inverse, it's only allowed to give angles up to pi over 2 and down to negative pi over 2. So that is, of course, why it's giving me this negative answer. So again, that is the answer. And just to kind of confirm, you could do this. Now that I know the angle, sine of that angle, negative 0.730, it better equal the y-coordinate. Guess what the y-coordinate is? Negative 2/3. Negative 2/3 is negative 0.66. Now again, of course, a little bit of rounding here. It's not exact because I rounded that angle. But, actually, if you really want to be exact, check this out. You could do sine, and then you could go up and grab all of those decimals, and then look at that. Now we get exactly negative 2/3 for the y-coordinate. All right, but what if I didn't want that angle? What if I specifically wanted a positive angle? I wanted the angle that went all the way up and around to end right here. Well, I just have to use my common sense. A full circle has 2 pi. 2 pi radians. 2 pi. So if I take that 2 pi and subtract away the 0.730, that is the negative angle, I'll be left with the positive angle that goes all the way around, 5.553. So the positive angle that goes up and all the way around is 5.553. And just to check that this should work out, check this out, sine of that angle, I'm going to use all the decimals for accuracy here. Oh my gosh, negative 2/3 yet again. Once again, the calculator is doing a little bit of rounding. In fact, I rounded the 0.730, so there's always a little bit of rounding going on, so that's why it's not exactly negative 2/3, but it's close enough, negative 0.666. I mean, do you see the connections? Let's try something else here. Let's try tangent real quick, just to confirm tangent, right? Tangent of 5.553 is negative 0.895. So we already know the tangent. We know exactly what tangent is. Tangent is negative 2 radical 5 divided by 3. Oh, I'm sorry. Oh my gosh, not divided by 3, divided by 5. Hey, about negative 0.89. Now again, I know it's not exact. That's because of the rounding I did, but you get the idea. It's really darn close. And again, you could find theta using sine, cosine, or tangent. So, but we got to think. If I use inverse cosine, so if I pull the old switcheroo with cosine, inverse cosine of radical 5 divided by 3, notice it gives me 0.7297, or again 0.730. But notice it's positive. So it's giving me this angle right here, the positive 0.730. Now, why is it giving me that angle? Well, because these two values, and even though my picture's not drawn very well, they're symmetric, right? So they do have the same x coordinate. Because again, if I'm using cosine, then that means I'm only focusing on the x coordinate. So this x coordinate up here is going to have the same x coordinates down here. I apologize, it's not drawn perfectly. This one should be a little bit higher. Okay, maybe up around here a little bit. Okay, just make it really big and cover up my mistake. So again, that's the limit, right? Cosine inverse is only limited to giving you certain answers. That's why you have to understand, okay, that's clearly not the answer I want. That answer is not in quadrant 1. The answer is in quadrant 4. So you could do two things. You could, A, just make the negative angle. Instead of going up, go down. That would land me in quadrant 4. Or I could, again, do the idea of, taking 2 pi, the full circle, and subtracting that 0.730, which is this angle right here, and I'll be left with, again, with the 5.553 radians. So I'm really hoping you see all the connections, all these little teeny tiny connections. All right, let's do a couple more problems that are going to make everything connected. All right, consider the point 4, -6 that lies on the terminal side of an angle in quadrant 4. Find 3 angles whose terminal side contains this point. Give answers in radians rounded to 100th place. All right, so sometimes a picture really helps. I'm going to draw a picture of this. This is the point in quadrant 4, over 4, down 6. So it's somewhere right around here, 4, -6. Now, this is clearly not on the unit circle because my my y value is bigger than -1. It's lower, right? The unit circle has a low point of -1. I'm down here at -6. And the x coordinate's bigger than 1. So again, I'm not on the unit circle, and that's okay. Don't fret. Don't worry too much. I'm just going to have to find my r value. Because remember, x squared plus y squared equals r squared. So let's go ahead and find that r value real quick here. So x squared is 16, y squared is 36, equals r squared. 16 plus 36 is 52. 52 equals r squared. Take the square root of each side. 52 is divisible by 4, so it's 4 times 13, so that's 2 radical 13. Always got to reduce square roots, equals r. Now, r is always positive. So now, to find the angle, right, it actually wants me to find 3 angles that terminate at this spot. So you could use sine, cosine, or tangent. I don't care. It's completely up to you. Let's use sine just to show this. So sine of the angle equals y, -6, over r, 2 radical 13. Now, of course, I don't like that radical in the denominator, so I'm going to rationalize to get -6 radical 13 over 26. Radical 13 times radical 13 is 13, times the 2 is 26. Oh, but now I could reduce this even more. So sine of theta equals 6 and 26 are both divisible by 2, so I get -3 radical 13 over 13. Okay. So now that I've finally figured out what sine is, now I could pull the old switcheroo. If I use an inverse sine and I plug in that -3 radical 13 divided by 13, I will get my angle. But again, I want 3 answers. So this will give me one of them. So I'm going to do an inverse sine of -3 radical 13 divided by 13. A lot to type in there, I realize. And I get -0.983. Now, again, I am in radian mode, so that is in radians, and the question did ask me to be in radians. So the answer is -0.983. -0.983. If you are obsessed with degrees, well, then put yourself in degree mode and do it on there. So right here, there it is, -0.983. So how do I find more answers? Because I want 3 answers, 3 different angles that all end at this same terminal side. Well, one thing I could do is I could find the positive angle that goes up and around. So to do that, I'm just going to take 2 pi, because 2 pi is a full circle. 2 pi. I'm going to subtract the 0.983, and I get 5.300. So another angle that ends at that terminal side is 5.300. All right, how can I find more angles? Well, every time you add 2 pi, guess what? You got yourself another answer. Add 2 pi again, you got yourself another answer. So there's actually lots of answers out there. Or you know what you could even do? Subtract 2 pi. Every time, you're going to get that value. Now, one way to check this, let's actually use this 17.867 to check. Tangent of that angle is equal to the y coordinate divided by the x coordinate? Well, that is -6 divided by 4. Look right there. The y is -6, x is 4. Oh my gosh. Now, why aren't those two things exactly the same? Rounding, guys. Rounding, please. They're close enough. -1.499 is pretty darn close to -1.5. So I'm confirming that I'm right. I'm confirming that all of this connects. Okay, I'm going to keep going here because this is important. This is good stuff. All right, another example. Given sine of x equals -0.36, and it does tell me that x is a positive angle from 0 to 360. So I'm definitely a positive angle. I'm not negative. I'm from 0 to 360. Find the angle in degrees and in radians. Well, that's just a matter of switching my mode. So what is x? X is an angle. Angles go into sine, cosine, tangent. What is the -0.36? That is a y coordinate from the unit circle where this angle stopped. So let's draw a picture. All right, so here's my circle. A y coordinate. Again, I don't know anything about the x coordinate. The y coordinate of -0.36 may be somewhere right around here. And I actually see that there's two possible answers. There's this point right here, and there's this point right here. If I draw those angles, here's one of them. And that angle definitely is going to have a y coordinate of -0.36, but so would this angle, or I could go down and get that angle. Again, there's lots of options here. But the point is that there, in the unit circle from 0 to 360, a full unit circle, I do see that there are two places that have a y coordinate of -0.36. And without knowing cosine or without being told specifically what quadrant I'm in, could be either one of those angles. So how do I find both of those angles? Well, let's do degrees first. So I'm going to go ahead and put myself in degree mode. Again, sometimes working with degrees is more visual because you see degrees because you've just been working with them for so long. All right, so let's see here. So how do I do this? I'm going to pull the old switcheroo. So I'm going to do an inverse sine of -0.36. Now, hold on. Remember, inverses are only allowed to give one answer. The only answer they're going to give me is the answer up to 90 degrees or down to -90 degrees. So there it is, -21.100 degrees. -21.100 degrees. That is the angle. Now, that's going to be this negative angle that goes straight down. But again, I did tell you that x, the angle, was in between 0 and 360. So one thing I should probably do is take a full circle, 360, and subtract that angle, 21.100, and I get 338.9 degrees. 338.9 degrees. So that's a better answer because that angle is between 0 and 360. So that angle is the angle that goes all the way and around and right here. So again, this angle that the calculator gave me was the -21.100 degrees. That's this angle right here. Sorry, my picture is getting very filled. But again, I didn't want that answer. Why? Because I told you that I was positive between 0 and 360. But there is a second answer that you have to truly understand, and that's the answer. Let me draw this picture better. It's getting really messy, sorry. So once again, here is my y coordinate of -0.36. And again, there's two answers. This point right here has that y coordinate, and so does this one. The difference between these 2 points is the x coordinate, but I didn't give you the x coordinate, so I don't know it. And again, here it is. This is the -21 degrees they gave me. So the first thing I did was I said, hey, let's take a full circle 360 and go all the way around to get the positive angle, 338.9. But what about this angle that also has a y coordinate of -0.36? Well, once again, to find that angle, I have to use my brain. If this right here is 21.10 degrees, so is this. So the red angle would be 180 degrees, a half circle, plus that 21 degrees. So 180 degrees plus the 21.100 is going to land me at 201.1 degrees. 201.1 degrees. So there is another answer. So there are two answers that at least fall within 0 to 360, and that's 201.1 degrees, 338.9 degrees. This value is definitely an answer, but it's the negative answer that I didn't necessarily want. Now, again, let's make connections in this video. Let's actually confirm that I am correct. Hold on a second here. Okay, so let's do sine of the 201.1 degrees. Sorry, typo. Input angle, output better be a y-coordinate. Oh my gosh, negative 0.36. Why is it not exact? Because of rounding. Let's try the other one, sine of 338.9. Oh my gosh, negative 0.36. It's not exact because of rounding, but you get the connection. And again, I could even do sine of the negative 21.1 degrees. And oh my gosh, I'm getting that same y value. But again, the negative 21.1 degrees really isn't in the proper quadrant. Or again, it's negative. I wanted the positive angles. So there's a lot going on here, I realize, but I'm trying to really slow things down. I'm trying to so that you could see all these teeny tiny connections that are going on here. So there's a part 2 coming up for miscellaneous because there is a lot of miscellaneous. I'm really good at, I really want to make a ton of connections here. So be ready to watch part 2 as well. All right, that's it. Hopefully you guys understand.